Hey everyone, it's Carmelia Ray here, back with Dr. Sanjeev Goel, and we've been a bit on a break for the battle to end Alzheimer's, and that's partially because we were both busy, but he also just came back from, or just received his results from the Toronto Memory Clinic of his PET scan, and other good news to share. So,
sure, yeah. I think I may have mentioned in previous episodes that I was going to go for a PET scan to look for amyloid deposits in my brain.
Correct.
Because I was just concerned, because I have the one allele, APOE4 allele.
Yes.
That did put me at higher risk, and I don't feel like I'm as sharp as I was when I was 20. So
I don't feel like
maybe
I was
a lot of us
sharp
feel.
as I was yesterday, but anyway.
So I went for this scan, and it was a couple hours. You know, it's like a CT scan. You go underneath this, go into a big machine. They give you a little medication so like they can kind of trace this amyloid and see if it's building up in your brain.
Right.
And
because whatever that medication is supposed to attach to those amyloids.
Basically,
okay.
yeah. And attaches.
What happened?
Yeah. So luckily, I have no amyloid deposits at this time. No increased amyloid deposits.
That's great.
Which is really good news. And I was kind of wondering, okay, what would I say if there was? But at this moment, we're clear.
Okay,
but that doesn't mean we're out of the woods yet.
Sure. Sure.
But so that's interesting. But I think kind of led me to this next study I want to tell you about, is that APOE4 is one of those genes where it's not always a bad thing.
Okay.
Like, yes, we think about it that it provides increased risk to Alzheimer's. Like,
yes.
There's
studies that show that, right?
It does, yes. Yeah. It's a clear double
indicator.
Double APOE4 is a 10 times risk for Alzheimer's, lifetime risk, and a single APOE4 is a double lifetime risk.
Right.
And there may be other genes as well, but APOE4 is clearly
one of those markers.
Risk. Yeah. It also puts you at increased risk of cardiovascular disease. So not a great thing.
No.
But it seems to have benefits for less amount of reduced risk of multiple cancers.
Okay.
And we do know that it's probably had an evolutionary benefit. That there'd be less chance of brain infections like meningitis or so on, because you have more of a reaction.
Okay.
Like your body is able to mount more of an immune reaction if you have an
to those particular things.
Yeah.
Okay.
So
it's kind of weird.
It's kind of interesting. So this whole idea of what we call pleiotropy, which means that a gene can have multiple effects, and sometimes or usually they'll have effects which are good, and they may have effects which are bad, because you can imagine if a gene was always positive, it would take over and be in everybody.
Sure.
But the fact that it's kind of nuanced and it interplays with the environment, kind of makes it that's why certain people have the gene, certain people don't. They have, there are...
Yeah, I wonder what the selection process is to say, you're going to have that APOE4, you're going to have 2, and you're not going to have any.
Well, I mean, you're playing
genetics.
A little bit of a genetics.
Okay.
Exactly. You're playing a bit of see what your parents have. But why is it even sticking around?
Sure.
Is because there's probably some advantages to having APOE4. And so what this study looked at was they divided the people who had APOE4 and then at death had Alzheimer's and high deposits of amyloid and neurofibrillary tangles, the tau tangles. They looked at those people, and what they found is those people obviously died and had a higher risk of dying. But then there were other people who didn't have the buildup. At all.
Even having had the gene.
Even though they had the gene.
Okay.
And those people actually outlived regular people.
Okay.
So what that's telling us is that
that's one
not
of the
always
positive. Yeah, that's one of the
always
positive.
a death sentence.
Right.
It means that you could fall into the group, even with an APOE4, of people who don't have any deposits and outlive everyone else.
Would that be true of someone with a double APOE4 like Chris Hemsworth?
Yeah, it's possible.
Okay.
Again, it's not the deposition's not. It's not 100% guaranteed.
Right.
There are other factors that are influencing that, and we
Well, knowing that could help to settle somebody's thought that if they have APOE4, oh my God, I'm really at risk.
Yeah, it's not doom. It's
not doom and gloom.
Exactly.
Okay.
And I think that's the point of this article, and that's
Sure.
what I want to kind of share with everyone, is that there's hope. And it's,
right.
again, it's take those preventative measures, like exercise,
Correct.
eating properly.
Well, you might not die of
smoking.
cancer either,
Yeah.
right?
Exactly.
Yeah,
Avoiding
'cause-
smoking. All of those things are
Yeah.
really important. And and there's lots of hope here. The second thing I want to talk about was this idea of what we call senescence.
Okay.
Which means that one of the theories about aging is that our cells get older and eventually stop dividing and fall asleep. We call senescence.
Okay.
And once they fall
Sounds
asleep,
like my afternoons.
once they fall asleep, then they release chemicals or signals to all the cells around them to also tell the cells to fall asleep, and release what we call inflammatory markers, because inflammation is the driving force of aging.
So once one starts, they fall asleep. It's like they recruit.
They recruit more, and they
more
send
and more.
signals.
Okay.
Hey, you need to fall asleep. You need to fall asleep. And so what's happening is that they have shown that aging animals have more of these sleeping cells.
Got it.
And so one of the thoughts is, let's get rid of these cells.
Right.
We can't tell them to stop. We can't reverse it. But
But
what we can do is,
how do you remove it?
so they have these. There have been like certain molecules. One is in this study with ditastinib and quercetin. These are, one's a medication, one's a supplement found in various foods. They have been shown in rats to decrease senescent cells.
Okay.
And they looked at in this study to see how safe are giving these molecules to
Humans?
patients with Alzheimer's. Yes, humans.
Alzheimer.
And they found it was very safe, and it seems to have a tendency towards reducing some inflammation markers. But the interesting thing here is to say, look, we have some other ideas on how we could potentially deal with Alzheimer's and
Correct.
other aging diseases as well by what we call senolytic therapies. So lytic means to destroy.
Okay.
Seno means the senescent cells.
Right.
So we can
Destroy the sleepy cells.
destroy the sleepy cells, and
Get rid of them.
That's a whole way. It's a whole avenue of attacking aging. So people.
How do they even isolate where the sleepy cells exist?
It just kind of goes in, like, so you basically take these in by mouth or maybe it was intravenous, but you basically take these in and it goes into your whole body, and they go in and basically.
And they find the sleepy cells, and
and it does that.
But those sleepy cells, could they be anywhere?
Yeah, they're anywhere in your body, everywhere in your body. These sleepy cells are building up as all of us are getting older, and that's
because when you're young,
as
as you're talking about cells dividing, that's why we're growing, right?
Mm-hmm.
And we're more youthful, I guess. But then when they stop dividing, they fall asleep. We start to look dead, I guess.
Yeah, what happens is that we don't know exactly why they fall asleep, but there are telomeres on the ends of the chromosomes.
Okay.
And every time a cell divides, the chromosomes shorten.
Until they can't
function anymore,
Okay.
until the cell can't divide any further. Well, the cell can't divide any further. It enters into a different state.
Right.
And it's called the senescent state. And then it releases these molecules to everywhere around it, saying, hey, I'm asleep, and I think you should fall asleep too. And I'm going to mess up the immune system. I'm going to make things more inflamed. Confusing signals get sent.
That sounds like a real anti-aging cure, or like a slowing process.
It seems
isn't it?
very promising. I mean, again, studies are just happening now. That in some animals, the studies have been quite promising, and we could maybe talk about it another time.
Sure.
But I think it looks like this could be a very interesting way of addressing Alzheimer's, which is really a disease of aging.
Yeah, and the fact that you're referring to aging as a disease, because that's been a new concept for some people, right? People think aging is just a process, but
it's not just something we have to accept. I mean, that's a very important thing.
I don't accept it.
Exactly. I think that we need to start thinking about it as a disease, and that we should be looking for a cure.
More proactive in our approach to anti-aging, right?
Yeah.
That's awesome. Well, in terms of the Toronto clinic, the memory clinic, you got your results. What was the time frame from the PET scan to you waiting?
Oh, just a week or so.
A week or so? Okay. Well, there you go. If you have enjoyed the channel and you like the channel, you can always support us by subscribing, hitting like, and sharing. And as well, you can go to Peak Human Rewards.
I think the URL is peakhuman.ca.
Yeah,
and
/rewards.
Yeah, and then go to the rewards section, and please, you could support us, because this is just a passion of love. We're not making any money on it.
I know.
We can definitely use your support so we can make better videos and give you more content.
And with that, we will see you next time.
Bye.
Bye.